Hi everyone, today we are going to solve systems of equations using matrices, but before we do that we want to start off with just a little refresher from just solving systems in general from your previous math classes. So the first thing we have is graphing. Solve both equations for y and put them in the calculator. So here's your example. This one's already solved for y, and on the second one we want to go to, subtract the 5x. Divide by the -4. And then we can just put that in the calculator exactly like that. So we can go ahead and show that. If you hit y equals on your calculator, put the first one in there, -3x, make sure you choose the negative, plus 5. Put the second one in there, use parentheses for the numerator, -3 minus 5x over -4. Hit graph. Oh, mine's in a statistics mode, so let's make sure we turn off all of our plots, etc. And then zoom 6 should graph it. Get it back to normal. And then to find that intersection, that's where the solution is, where they intersect. So second trace 5, enter, enter, enter. And our solution is going to be 1, 2. So we can write it like 1, 2. It's an ordered pair, and that's the solution that satisfies both equations. And so that is our solution here. All right, let's do another method, substitution. So for substitution is when you want to have one of the variables by itself and equal to the rest. And so we'll just take this one and solve for y. We'll add the 5x over. And then we use what y equals in the other equation to solve. So it's going to be -3x plus 3 times 5x plus 13 equals 3. This one's a great one if one of the variables is already by itself and it is simple to solve for it, or it's simple to solve for it. So you can just plug it right in, and then you only have one variable now. Distribute. We get 12x equals -36, which makes x equal to -3. And then now I know y equals 5x plus 13, so to find y, I'll plug in that -3, kind of substituting again. And -15 plus 13 is going to be -2. And we again write our answer as an ordered pair in the form of y, x, y. So the first one, graphing, you want to use if you have something easy to solve for y. Here, you want to plug one equation into the other. Easy to solve for y again. And then this other one, elimination, is what you want to do is if you can make both, if you can line them up and make both of the coefficients the same sign but opposite. So in this case, I can change all the signs of this bottom one by multiplying by -1. Distribute that, and I get 4x plus 9y equals 23. So I'll just cross this one off now and ignore it. Then you just add straight down. So -2x plus 4x is 2x. -9y plus 9y cancels, that's the point. And -25 plus 23 equals -2. So we eliminate a variable by making the coefficients the same with opposite signs, and then solve for the remaining variable. So x equals -1. And then I just take that top one and solve for x. So that's going to be 2, or solve for the other variable. -9y equals -27, and y equals 3. Again, let's write our final answer as an ordered pair here. And so that's the ordered pair that satisfies both equations. You can do any method for any of the three methods for any problem at all, but there are times when one is easier than the other. So just use your best judgment. And then in this case, we're going to start getting really complicated with 3 variables, And so we really only have two ways to do this because we don't use three-way graphs too much yet. So the intersection with the graphing, neither our TI-84 nor Desmos can do three-dimensional graphing at this time. Substitution, it's hard when there's three variables because you're not getting rid of one. And so we'll just practice elimination to start. If I look at these three rows of equations, I can see some things right away that they could be eliminated, like this equation and this equation can kind of go together. And if I were to add those as is right now, I'll just move the bottom one right underneath it. Then just highlight that again so you can see where it went. Moved it to the bottom. Then I can just eliminate it right away. X minus x, 5y minus 5y, and I get negative 6z equals negative 18. And now I was able to eliminate two of the variables at once. And I know now that z equals negative 3. So then I want to be strategic and try to eliminate another variable. This time I'm going to look at, I think, these two equations because I can eliminate the y, but I know what z is. So that's what I'm going to focus on next over here. We have 4x minus 5y plus 4 times negative 3 equals 19. And I have x plus 5y minus negative 3 equals negative 20. So I can clean these up a little, make it a little simpler. 4x minus 5y equals, and we'll just do 19 minus 12, and then x plus 5y, and we'll do negative 20. That's a minus 3, so we'll add 3 and get negative 17. And now I can eliminate the y. I have 5x equals negative 10, and x equals negative 2. So far now I eliminated two variables from these two equations to find z, then I plugged z in and eliminated the y to find x. And now I'll just take that top equation. I haven't used it yet. I don't have to use it, but I can just take that top equation and solve for the y now. So I have negative, I know x is negative 2, minus 5y minus 5z equals 2. So we'll just clean this up a little. That's 2 minus 5y plus 15 equals 2. And then the 2's cancel, subtract the 15, negative 5y equals negative 15, and y equals 3. And so then, just like we've done before, we're going to write our answer as an ordered pair, and it goes x, y, z. This is a three-dimensional situation. Can label them for you. We have x, y, z. So z adds a third dimension to the graph, and so it is the solution for this. All right. But that was going to take a lot of work to do that every single time. It definitely works if you can figure out which pairs to put together and use elimination, and you can just do it like bit by bit till you whittle it down to the three solutions, one solution with three values. But we do also want to think about doing some inverse stuff. So remember, when sine of x is 1/2 means that inverse sine of 1/2 equals x. We do second sine of 1/2, and so we weren't dividing by sine, we were taking the inverse of sine. We can also think of that same exact thing, but with solving systems and matrices at the same time. So the way that's going to work is, here's the matrix, super cute little picture, because it's all about matrices now with systems. So we can let A be the coefficient of all the matrices. We can let X be all the variables. We can let B be all the answers. And so if we take the inverse of A, then it will find all the variables for us. Okay, so let's just see how that works. Like I said, if using your matrix rules that you learned the other day, we can rewrite this like, all of the coefficients, -1, -5, -5, 4, -5, 4, 1, 5, -1. And then we can just pull out the variables like that. And so we can say like this is A and this is X. And then it equals, remember 3 by 3 matrix times a 3 by 1 matrix is another 3 by 1 matrix. We can call it matrix B and say 2, 19, and 20. So if I want to find this variable matrix right here, then I can do inverse of A times B equals X, just like we kind of did with our sine function and stuff. And so what you do is you just put all the coefficients in a 3 by 3 matrix. So -1, -5, -5, 4, 5, 4, and then 1, 5, -1. And then you multiply that by your solutions. And then that will get us a new matrix with the answers. So I'll show you in my calculator how we do that. You can also use Desmos if you'll remember the rules from using Desmos before. But I want to show you the calculator because it's not as intuitive as Desmos. So hit second matrix, and then you go over to edit. Hit enter. And so we want to do a 3 by 3 matrix first for matrix A. And then what you do is you type the numbers in. So -1, -5, forgot to hit enter on the first one. So -1, enter, -5, enter, -5, and it goes across. So then we do 4, 5, 4, and then we'll do 1, 5, and -1. Okay, so that is our matrix A. We're filling it into the calculator. I got there from second matrix, and then I made matrix A in the edit screen. So then I'm going to go over to edit again and make matrix B, which this time is a 3 by 1. And so we'll put in 2, 19, and -20. And then we do exactly what it says. We want to do the inverse of A times B. So we're going to hit second matrix, pull up matrix A, hit the inverse button, and then times it by second matrix, pull up matrix B. Hit enter, and I made a typo. So let's go back and look at my typo. Okay, -1, -5, -5. 4, oops, there we go. See my typo. -5, 4. Oops. It's because I did it on the screen here too. And then 1, 5, -1. So I had made a typo. We've already done this problem, so I knew the answer. And there we got the right one now. So x equals -2. I'm going to minimize my screen. -2. Y equaled, oops, I gotta pull it back up. -3. Z equals -1. So you see how it's lined up with the x, y, and z, like I had said, how we could pull them out. And so we will write it as an ordered pair, -2, -3. Oh, why did I put -1 there? That's not the answer. It's 3 at the end. So. Okay, so that is the same answer we got before, doing it by elimination. And so you just have to take the coefficients, put them in a matrix. Basically, this is what you want to know is that it's A -1 times B equals X. And so that means that's the coefficients. B is the answers. And then that equals your variables. So let's practice one more. And I'll show you this one in the calculator again. And so that way you make sure you know how to use it. So hit second matrix. Go over to edit. We already have it set up as a 3x3, so we just need to replace the coefficients. And so we have this time -4, -5, and -1. The next row is -2, -5, and -2. And then the last one is -2, 5, 2. And you just want to make sure you got them right because I messed up before. -4, -5, -1, -2, -5, -2, -2, 5, and 2. Okay, so then we go back to second matrix, go to matrix B, and let's check our solution matrix. We have 18. So it's a 3x1. We want 18, 12, and 4. And then we go to the main screen and we can just hit enter because we just did this, a to the -1 times b, and we get -4, 0, and 2. And so if we wanted to fill this in, should have maybe -4, -5, -1, -2, -5, -2, -2, 5, 2, 18, 12, 4, and that gets us 4, 0, and -2. -4, 0, and -2. And we want to write those as an ordered pair like that. And then we will highlight this. And that's our answer. I do want to quickly just show you guys, remember how the Desmos, because that's going to be just as easy. So remember, you go to desmos.com/matrix, and then you can type a new matrix. We want it to be a 3x3. Matrix A is -4, -5, -1. We have -2, -5, -2, and -2, 5, 2. Do another new matrix. This one will be a 3x1, and so we have 18, 12, and 4. And then you have to type A, -1 times B, and then it gets us that solution 4, 0, -2. So the Desmos is obviously a lot faster, but the TI-84 is good to know too, just in case you wanted to use your calculator, tried and true calculator. All right, well, let's see one more thing I want to show you guys. We have a quick little visual of the three-dimensional coordinate plane. So we have, Xmas, Ymas, and then the Z. That's what's the third dimension is the Z, X, Y, Z. So I hope you guys have a great day and check Canvas for your next assignment. Thank you.